All right, so today we are finishing up section 2.3. In the last lesson, we looked at polynomial division. We looked at long division and synthetic division. So today we're going to be doing some applications for synthetic division. So synthetic division is a handy tool, and you will see that in this lesson. So we'll get going starting with the remainder theorem. So I'm on page 19 of your note packet, starting with the remainder theorem. So basically what the remainder theorem says is if you have a polynomial, we'll call that f of x. If you have a polynomial and you divide it by the divisor, we'll call the divisor x minus k, so k would be your constant there, then your remainder equals that function. Take that function and plug in the constant in for x there, and that gives you your remainder. So basically what that is saying is that if I plug in, so look at number 10, if I plug in 2 for x, whatever that simplifies to, that is my remainder. But we also know that when you do synthetic division, that last number in the quotient is your remainder. So let's look at how this all plays out. So here's our first learning target. I can use the remainder theorem and synthetic division to find each function's value. All right, and then we're going to verify our answers as well. So first we're going to use synthetic division. So for number 10, f of 2, so f of 2 means that our divisor is x minus 2. This would be our divisor here. So if the divisor is x minus 2, how did we get that positive 2? Well, if you remember, you set it equal to 0. You set the divisor equal to 0 and solve for x. So I would add 2 to both sides here, and I would find that x equals 2. So this is actually the value of x. 2 is the value of x, and then that makes x minus 2 the divisor. So when you divide using synthetic division, you always take the value of x here. So I'm going to divide with the positive 2. And then as we learned yesterday, you're going to take each coefficient here for your dividend and make sure it's in standard form. So 3, 2, 1 constant. We're good to go. And if you were missing a term, you would fill in zeros as we learned yesterday. Okay, so let's just keep tally of our success criteria here. So step 1 is to use synthetic division, and that's what we're doing right now. Use synthetic, I'm just going to abbreviate, division. All right, so how do you do that? Well, you bring down the 2. We learned this yesterday. Bring down the 2 to start. That first number comes down, and then you start with the pattern of multiply, add. So multiply 2 times 2, that's 4. And now add straight down. Negative 8 plus 4 is negative 4. Do your process again. 2 times negative 4, that's negative 8. Add down, 10 plus negative 8 is 2. Multiply again, 2 times 2 is 4. Add down, negative 7 plus 4 is negative 3. So what did I just find here? Well, I found the quotient. The quotient would be 2x squared minus 4x plus 2, which means that the remainder is negative 3. That's our remainder, negative 3. So to verify it, we're going to use our remainder theorem, which says if I plug in my constant of 2 here, then plug that in for x, it should equal my remainder. So it should equal -3. So let's check it and see if we did this correctly. So I do f of 2, and I'm going to plug into for x. Okay, going back over to our success criteria here. So let's recap. We did our synthetic division. What did that tell us? It told us the remainder. So the last number of your quotient, this is our quotient, is the remainder. I'm just going to call that R there. And then we're verifying it now. Now we're in the step where we're verifying it. So we're verify by plugging in our f of k here. All right, so we're plugging in k, 2, in our case, in for x. All right, so k for x in the equation. And now all we have left to do is simplify. So after you plug it in and simplify. All right, so let's go ahead and simplify this. So I'm going to do 2 to the third first. So 2 to the third is 8, and then multiply 8 times 2, that's 16. And then 2 squared is 4, times -8 is -32. 2 times 10 is 20, minus 7. Then we'll just throw that in the calculator real quick, and you would get -3. And that verifies that if you divide by x minus 2 here, then you get a remainder of 3, -3. All right, pause the video, try number 11 on your own. All right, let's see how you did for number 11. So using our success criteria, first we need to use synthetic division. So I'm going to take my value of x, so x equals -2 here. And then fill in my numbers up here from my dividend. So 1, 5, -4, -20. And then I'll start my process by bringing down the 1, and then multiply, add, multiply, add, multiply, add. So the last number here, last number is my remainder. So this has no remainder. So what that means is when we plug in -2 in for x here, we should get a 0 because there's no remainder. So that's the verification here. So f of -2 equals, kind of tight on space here, but you would do -2 to the third plus 5 times -2 squared minus 4 times -2, and then minus 20. Simplify that all down. Show you this step here. Throw that in the calculator, and of course, you would get 0. And there's your verification here. All right, so that is the remainder theorem. So let's move on. So we'll turn to page 20 now. And we're gonna look at the factor theorem. All right, so the factor theorem says that the polynomial f of x has a factor of x minus k if and only if f of k equals 0. So in order for this to be a factor, you have to have a remainder of 0. This is our remainder. Remainder has to be 0 in order for this to be a factor. And that's what the factor theorem is saying. Okay, so that's important here. All right. So that pushes us into our next learning target here. I can use synthetic division. So here is yet another application of synthetic division, such a handy tool. I can use synthetic division to show that x is a solution of the third degree polynomial. So that just means it starts with an x to the third degree. And then we're going to use the result to factor completely. And then once it's factored completely, we can give what x equals. Those are the solutions there. All right. So we're going to start by using synthetic division, okay? Let's see. Tally up our success criteria over here. So step 1, we're going to use synthetic division. Just gonna abbreviate there. So we'll set that up. X equals 3. So I'm gonna start with 3 for my divisor there. And then fill in my coefficients here. Bring down that first term, my 2, and then start the process of multiply, add. So multiply, add, multiply, add, multiply, add. Okay, so I have a remainder of 0. So what does that tell me? That tells me that when I have a remainder of 0, then this is a factor. So x minus 3 is a factor of this polynomial. So let's find the rest of the factors. So if I divide here, I end up with this as my quotient. So my quotient would be 2x squared, remember you go down 1 degree there, plus 3x minus 2. So I can take this quotient and factor it to find my other factors. So that's my next step. So after I find my quotient, I'm going to factor it completely. So factor the quotient obtained from your synthetic division. Okay, here's my quotient. Let's factor it. So this is a trinomial where a is greater than 1. So this is where we have to factor by grouping. So we do 2 times -2. We get -4 there. And then we're going to find the factors of -4 that add to 3, because we're going to replace that 3x. So that would be 4 times -1. So I'm going to replace 3x with 4x minus 1x. All right, then I'm ready to group. And I'll pull out my 2x here. Pull out a -1 here. They're the same, we're on the right track. So it's factored as 2x minus 1, so 2x minus 1, and then x minus 2. Now, notice that this is the factorization of the quotient. I want the factorization of the whole thing. And I know already that x minus 3 is a factor. So x minus 3 is a factor, 2x minus 1 is a factor, and then x plus 2 is a factor. So I'm going to pull this down here to have my complete factorization. That would be the complete factorization of our polynomial. So that's what we were trying to do. We were trying to factor completely to find all the factors. Now we want to find the solutions. We want to find what x equals. So let's do that. So how are we going to do that? We're going to set each factor equal to 0 and solve for x. Set each factor equal to 0 and then solve for x, and that will give you your solutions. So I'm going to do 2x minus 1 equals 0, x minus 2, or x plus 2, sorry, equals 0, and then x minus 3 equals 0. So you would add 1, divide by 2, so x is 1/2. Subtract 2 here, x is negative 2. Add 3 here, x is 3. So here's your factorization, and here's what x equals. X equals 1/2, negative 2, positive 3. Okay. Use your success criteria to try 13 on your own. So go ahead, pause the video and try 13. Okay, let's go over 13, see how you did. So you start by using synthetic division. So I'm going to pull that negative 1 and then set up my synthetic division. And bring down the 15. And then we will multiply, add, and multiply, add. I have that 0 remainder, so that means that this is a factor. So x plus 1 is a factor. Then I'm going to take my quotient. All right, and then I'm going to factor that so I can find all the factors. So I'm going to do my factor by grouping process here. Just running through this quickly to save some time here. Pull out my GCF. Okay, and then this factors as 5x minus 2 times 3x plus 1. And then, of course, don't forget about this factor up here, x plus 1. So this is factored completely. And then you would set each equal to 0 to find that x equals 2/5, negative 1/3, and negative 1. All right. Okay. So that is it for that. We have one more thing to go over. Sorry, this is kind of lengthy. So we'll look at our last learning target for today. I can find the remaining factors of f of x and then give the complete factorization and the zeros. So this is basically what we were doing before in the last couple examples, but now we're given more than one factor. So let's look at 14. So we're told that 2 factors of this polynomial would be x plus 2 and x minus 4. We want to find the rest of them. We're going to see if there's any more factors. So what we're going to do, again, we're going to use our synthetic division. So first step in our success criteria here is to use synthetic division. But now we have two choices. We could either start with x equals -2 or x equals 4. Doesn't matter. I'm just going to do the first one, the x minus 2. So we're using synthetic division with one of the given factors. So I'm going to start with this -2. Set up my synthetic division here using the given polynomial. Bring down the 1 to start, and then multiply, add, multiply, add, multiply, add. Of course, that zero remainder means that that is in fact a factor. So now we have x, go down 1, x squared plus 0x minus 16. Now, we're going to do synthetic division again. So we're going to take our quotient here, and then we're going to divide it by the next factor, 4. So 4, and then 1, 0, -16. All right, so that's step 2 in your success criteria. We're going to use synthetic division with that quotient and another given factor. All right. Bring down that 1, multiply, add, multiply, add. All right, so what's left over here? So this started with x squared, so this would be 1x plus 4, or just x plus 4. So that tells me that x plus 4, because it has a remainder of 0 here, x plus 4 is also a factor of this polynomial. So what are my factors? So right here, now, if this could be factored more, we would have to factor this more. And you're going to see that coming up in this problem. But since x minus 4 is in its, or x plus 4 is in its simplest form, it can't be factored, then that just becomes the factor. But step 3, if you could factor this, you would go ahead and factor it. So we'll just add that in here. Then factor completely if needed, but we didn't need to. And then finally, we're going to find the zeros. And we talked about that in our success criteria up above here. Finding the zeros, you set each factor equal to 0 and solve for x. So x equals, for this one, -2, and then +4, and then -4. And those would be our zeros, or our solutions. All right, go ahead, pause the video, try 15 on your own. Use your success criteria for reference. All right, let's check and see how you did there. So you're gonna start with synthetic division using 2 here. Set it up. Bring down the 2, multiply, add, multiply, add, multiply, add, multiply, add. Then you're going to do the process again with -3. This would have been x squared. I'm just going to fill this in. Oh, x to the third, just so I don't forget. Okay. And then do the process again with the other factor. And then multiply, add, multiply, add, multiply, add. All right, I have no more factors given for my synthetic division, so that means I need to factor this quotient. So I need to factor 2x squared plus 5x plus 3. And I'm going to save some time. I'm just going to give you that factorization. It is x plus 1 times 2x plus 3. All right? And then, of course, you would also use these factors here. So there it is, factored completely. And now we're going to find our zeros, find what x equals. So x, set each of these equal to 0 and solve. So -1, -3 over 2, +2, and -3. All right, that is the conclusion of today's lesson. You are ready to do your book work.